All right, question number 17. We want to make a complete graph. Says use graphing utility for locating intercepts, extremes, inflection points. Let's use the graph just to kind of get some practice with that. Let me write that down so we can have it right here. All right, so we're going to graph this one, and then we'll be able to pick the correct. Alpha y equal enter, make a fraction bar. 3x minus 5. Then x squared minus 1. All right. All right, so that looks good. We're going to graph it. Uh-oh, look like it just disappeared. Three x minus 5, x squared minus 1. Enter to lock it in, and then we'll graph. All right, so we can kind of see the shape of this graph. We can kind of pick out which one matches. So since our double parts on the bottom, we can get rid of A and B, and we're looking at C and D, and based on the shape, C looks to be the best one. So you can use the graphing utility. You can kind of see the graphs. You can trace it, plot some points. We could also go through those steps, find a derivative, set it equal to 0, find some of those max or min points. But you can get it pretty quick also using technology. All right, number 18, we want to use the derivative, determine the local max and minima, intervals of increasing, decreasing, and then sketch a graph. All right, so we have our derivative. The derivative is going to allow us to find the max and min and increasing and decreasing intervals. All right, so based on the derivative, we get critical values. X equals 3, x equals -1, and x equals -5. It doesn't say anything about any restrictions. -5, -1, and 3. All right, so we're going to do -10, -2, 0, and we'll do 5. All right, so we're looking for positive or negative, and then we'll be able to identify max or min. If I plug in -10, this term will be negative. -10, this term will be negative. This will be negative. So negative times negative times negative. Negative times negative is a positive, times a negative will be negative. So this will be going down. Plug in -2, this is negative. -2, this is also negative. This will be positive. So a negative times a negative is a positive, times a positive is going to be positive. So this section is be going up. So -5 will be a minimum. plug in 0, negative, positive, positive, this whole term will be negative. If I plug in 5, this will be positive, positive, and positive. So we have a min, have a max, have a min. Local max at x equals -1. Local minimums are -5 and 3. All right, so intervals of increasing and decreasing, just like what we have here. So we're looking for increasing interval, -5 to -1, 3 to infinity. And then 3. All right, decreasing intervals, -infinity to -5, -1 to 3. And then -1 to 3. All right, and then a potential graph. So we're looking for, it's coming down from left to right, up, down, and then up. So this is going up from left to right. Looks like we're going to have a 4th degree for the graph of f. So D is the best one, coming down, up, down, and then up.